Okay, I'm going to unfreeze the screen and I'm going to just focus on example B. I'm going to unfreeze the screen and I'm just going to focus on example B. Okay, so negative 3x squared plus 2x squared is negative x squared, or negative 1x. Sir, say again. What do you mean your question's already been answered? What was it? So why did I not put a 1 in front of it? Do I have to? Yeah, I'm lazy. I just don't write ones. Sorry. It's a lazy mathematician thing. I'm allowed. Would I count that right? Yeah, absolutely. It is right. We just don't have to write 1 because it's understood that you just have one variable. Okay. I write as little as possible. What's 6 plus 4? 10. Negative 5 and negative 7? Negative 12. Raise your hand if you got B correct. Thumbs up, whatever. Okay. Do you have a question about why, if you didn't get that, do you have a question about why you didn't get that? Okay. C, you guys didn't have to do C, but I want to show you that one. So notice on C, when I put this in standard form, I put my negative 2x first. Negative 2x squared plus 6x. And then I stacked below it 9x squared, negative 5x. And there's no constant to match up with my positive 6. That's okay. I'm still just adding these together. Negative 2 and positive 9 give me 7. Yep, so 7x squared. Positive 6 and negative 5 give me a positive 1x. There you go, Tyler. And then 6 plus 0 is still 6. Okay. And again, you guys didn't have to do number 6. Or sorry, not number 6, letter C. Did you? Did you get that same answer? Bonus. Good job. Okay, D. What's the problem with D before I show it? What's the first one missing compared to the second one? The first polynomial expression doesn't have a what term? Yeah, it doesn't have an x squared term. So when I wrote that first polynomial out, I left this space here. I just left a gap. Could I have put this number on the top and added this to it? Why? Why can I change the order when I do addition? It's worth a bonus point. It is going to add up either way. Why? 3 plus 4 is 4 plus 3. I agree. There's a property that you learned in algebra. Who said that? Treshawn, commutative property. Plus 1. Nice. Yeah, the commutative property, here's how I remember it. Lets you change the order. Commutative property lets you change the order. Okay. So a positive x cubed and a negative x cubed give me 0x cubed, which is just 0, so I didn't even write it. There's nothing to add my 4x squared to, so 4x squared by itself. A positive 1x and a negative 3x give me negative 2x. Negative 5, positive 1 is negative 4. Do you guys feel okay with adding? Yes? Okay. I'm going to skip number E, or letter E, and I'm going to go to the back. Go to the back. I want you guys to have time to work on stuff today, right? You don't have it yet. Okay. Yeah. Okay, here we go. So now we're not adding, we're doing what? We're subtracting. And you guys learned a long time ago that when you have a minus sign in front of a parenthesis, that is the same thing as doing what? Yeah, what do we call that when we make everything? Yeah, we're going to distribute. I'm going to write distrib the negative. We're going to distrib the negative. And I use those arrows across the top. When you see arrows on my paper, that means I'm distributing. So the first problem, the first polynomial term doesn't change. 7x squared plus 5x plus 8. But to that, I'm going to add, let's see, negative 1 times 2x is negative 2x, and that's squared. A negative 1 times a positive 3 gives me a negative 3x. Yeah, negative 1 times positive 1 is negative 1. You have to distribute that negative to every single item inside of the parenthesis. And then I just add them as normal. 7 minus 2 is 5, so that gives me 5x squared. 5 minus 3 is 2x. Yes, sir. And 8 minus 1 is perfect 7. Okay. Do you guys want to do B by yourself, or do you want to do B together and then you do example 4? Do B by yourself. I think that's a great thing. I'll freeze the screen. You guys do B by yourself. Quick Sway, you want to shout out your answer? Trayshawn, go ahead. Absolutely. Negative 3x squared plus 5x plus 6. That's the answer, right? Okay, so look at this term right here. When you distributed this negative through, did you get this? Did your paper get that? So then you should get it right. What's positive 2 and negative 5? Oh, you're looking at my answer. What did you get on your paper? Are you even doing it on your paper, Colt? I know, but I gave you that because sometimes you don't focus. You should still try to do the math on your own. It's your notes. It's your whole note packet that I gave you on Wednesday, ding dong. Okay. You with us now? Okay. I didn't mean to call you ding dong. I apologize. Okay. Let's do example 4. So example 4 says find the differences. Remember to change the sum of the opposites and arrange them vertically if you need to. You don't have to arrange them vertically. You can circle them, but you always want to rewrite it. So again, I'm going to have to distribute the what? Distribute the negative 1. 4x minus 3x squared plus 8. And I'm actually going to rewrite that as negative 3x squared plus 4x plus 8. I'm putting that first one in standard form. A negative times a negative is a positive 6x squared. A negative times a positive is a negative 1x plus 1. So you should get 3x squared plus 3x plus 9. Make that nice and big so you guys can look at that. And then we're going to move on to multiplying. We're not going to do B. Is that okay? So again, this should be a review, right? You did all of this when you learned about exponents and polynomials in your Math 1. But some of you guys haven't been in Math 1 for a hot minute, right? Oh my gosh, you're loving that. Okay. Can I go on to example 5? All right, example 5. We're going to take monomials. A monomial is just a polynomial that doesn't have addition or subtraction in it. And we're multiplying them, okay? So when you have something like that, you have to think about the rules of exponents, okay? And so the rule is that when you multiply, I'm just going to kind of abbreviate it. When you multiply powers, that's what a number with an exponent is, right? It's called a power. If they have the same base, you add exponents. Okay. I'm going to show you why that works. So I'm going to do it the long way. You can come back here and sharpen your pencil if you need to. I'm going to do that the long way and then the short way, right? Because I think if you understand the rule, then that's good. So the first thing that you're going to do is you're going to take 5 times 2. What is 5 times 2? 10. Talk to me about what x cubed is. Well, x cubed is really x times x times x. Is that true or false? That is true. And x squared is really x times x. Here, bud. Yeah, you just add, how many x's am I multiplying together? 5 of them. You're welcome. So that's really 10x to the 5th, which is no different than what the rule says. The rule says if the base is the same, x is your base, it's the number that you're raising to the power, you add the exponents. 10 times x to the 3 plus 2. Well, 3 plus 2 is 5. So 10x to the 5th. So probably when you first learn this in Math 1 or even in pre-algebra, you learn, or Math 8, whatever you guys call it, you learn to expand them, right? So if you know how to always expand your exponents, then this won't be that hard. Example B, you have a negative times a negative. Negative 3 times negative 8 is a positive what? 24. The numbers that are being, yeah, who said that? Was that you, Colt? Good job. Remember that if there's no exponent on the variable, it's what? What power? 1. Good job. So that's why that rule works. 1 plus 1 is 2. Do you guys remember that? Y'all feel good about that? Okay. What about this one? That is pretty tricky. So let's multiply the constants first, or the coefficients. Let's see. 1/2 times 3/4. How do you multiply fractions? Just go straight across. 1 times 3 is, 2 times 4 is, perfect. So 3/8. So let's use the rule. I'm going to take these bases of x and I'm going to add these two together. So it's going to be x to the 11th. And I'm going to take the bases of my y and I'm going to add those exponents together. Y to the 6. 5 plus 1 is 6. Okay. Do we remember how to do that? You feel good about that? Okay. Flip flop. Turn it over. Turn it over. Okay. So after we refreshed our brains on exponent rules, then we had to do things like multiplying a number outside by a binomial. This is a monomial times a binomial. I take one term and I multiply it or distribute it through the parenthesis. So 2 times 3 is, and x times x is, perfect. And 2x times a negative 1. Well, 2 times negative 1 is negative 2, so it's negative 2x. Do you guys feel good about that? Okay. Example B, I have a negative 3x that I'm distributing to each term inside of the parenthesis. So I have to multiply the constants or the coefficients first. Negative 3 times a positive 4 is negative 12. X times x squared is x cubed. Good job. Remember, there's a 1 there. Okay. Negative 3 times negative 2 is positive. X times x is x squared. Good job. Negative 3x times 1 is just that, negative 3x. Do you guys feel okay with that? Yes? Okay. I'm going to just jump down to exercise 8. Just jump down to exercise 8. So when you had to take a binomial times a binomial, we took the terms on, we used this, we called it the box method. Do you guys remember doing this? It's called the area model, right? So the first parenthesis is on the outside, or like along the vertical, and then the second parenthesis along the horizontal. And each box you're going to multiply. So what is 2x times 3x? 6x squared. And then I'm going to take 2x times 4. 2x times 4 is 8x. And now I'm going to do this box down here, which has a 7 times a 3. 7 times 3 is 21. So I have 21x. And then this last box, positive 7 times positive 4 is 28. Notice that when these are all positive, notice that these middle terms right here can be what? Combined. Yeah, they have the same exponent, same power variable. So this is really 6x squared plus, what's 21 plus 8? 29x plus 28. Yeah. Example B, you guys can do the box method. I'm going to show you that you learned how to FOIL. I call it just distributing. X, right? If I take this term on the outside and I multiply it by each one of these, x times x is, x times a positive 9 is, 9 times x is 9x. And then I take the next term in my first parenthesis, negative 4 times x is negative 4x. And negative 4 times 9 is negative 36. Notice that you can combine these two terms in the middle. What is 9 minus 4? So I have x squared plus 5x minus 36. I don't know if you guys like the FOIL method better or the box method better. You can use either, right? Yeah, I want you to use either. And just so you know, typically, there's a whole bunch of boxes printed up over here, just because I know that you guys, I mean, it's for factoring, but you can still use them. So if you're doing, you're working in your Delta Math and you don't want to have to draw a bunch of boxes, there's already a bunch already drawn up over there. Okay, so help yourself. All right. So can we go to the next page? We're going to do 2 more examples. Yeah. Go to example number 9. 9's like the mega box, right? I know that. It's crazy, right? So this is called the area model, right? So I have a binomial, 2 numbers in one parenthesis times 3 numbers in the other. That's why there are 6 boxes. 2 times 3 is 6. So I'm going to put my 3x and my positive 2 along the vertical edge. And then I'm going to put my x squared, my 6x, and my 8. And these are all positive. I typically don't write the pluses. I typically only write the minuses. Okay. And then we're going to do the area. 3x times x squared is 3x cubed. Yeah, good job. 3x times 6x is 18x squared. Good job. 3x times 8 is 24x. Very good. 2 times x squared is 2x squared. 2 times 6x is, it's not x squared, just 12x. And 2 times 8 is, so notice, it's not always like this, but notice on the diagonals, you can combine these 2 terms together and you can combine these 2 terms together because they're the same variable to the same power. So there's no other x cubed term. That 3x cubed is not going to be grouped with anything. But I have 2x squareds. What is 2 plus 18? So 20x squared. What's 12 plus 24? 36x plus 16. Yeah. Okay. So I'm going to give you a choice. You can choose to do exercise 10, A or B. A or B. So I'm going to freeze the screen and I want you to do one of them. A or B. Parker, which one did you do? Give me a final answer. Simplify it. Perfect. When you guys are done, you can go ahead and start on go to your Delta Maths.
Oh.